Hello, everyone. I am Xavier Serra from the Music Technology Group at the Pompeu Fabra University in Barcelona. And I want to record this presentation that I did at the AES International Conference on Artificial Intelligence and Machine Learning for Audio that took place in London at Queen Mary University from September 8th to 10th. And I gave a keynote on this topic on ethical MIR research for trustworthy AI, principles, challenges, and practices. And the context of this presentation is very much related to my position at the Music Technology Group and the need to be able to carry out meaningful research in our current times, in the times where AI, of course, is the leading context in which we do all our research, and all the ethical issues are becoming a fundamental element for that. So I put together this presentation. And let me first start by talking about the concept of trustworthy AI, which is becoming a quite well-known concept. And that refers to what it says here, the development of AI systems that comply with the law, are transparent and accountable, and can be technically verified, fostering confidence among both stakeholders and end users. And especially at the European Commission and in Europe in general, there has been a lot of effort in trying to define that and to give guidelines that can be of use to all the relevant stakeholders. And of course, one of them are the researchers, that we have to develop technologies that basically should aim to support all these trustworthy AI ideas. And the core issue behind that are the ethical principles that are being discussed and presented, and that identify several aspects that we should pay attention to. So here I want to highlight not all of them, but some of the ethical principles that I believe that in our research in MIR are especially relevant. So the first one is this idea that we need to respect creative integrity, so that these AI systems should honor the originality, intent, and rights of musicians without exploiting or misrepresenting their creative work. Okay, so that's the core idea, that creativity emerges fundamentally from artists, from musicians, and that creativity is then used for doing research, is used for developing products, and we have to be very much aware about this origin of all these creative aspects, and the integrity that we should give to this aspect of musical creativity. So we should make sure that we honor this origin of all the content, all the data, all the aspects that we deal with. And then being more precise, one aspect is attribution and credit, so that AI systems should acknowledge and properly credit the creators whose works are used in training AI models. That's the most common aspect of ethics in music, in the idea that we should make sure that when we use content, works, pieces by artists, by musicians, by creators, we should make sure that we credit that. Okay. Another aspect in music is this issue of cultural sensitivity. Music is a cultural asset that is the result of a variety of cultural contexts. And therefore, AI systems should recognize, respect, and preserve the diversity of musical traditions, practices, and values. Okay, so that this this richness in musical culture that has resulted in the music that we have today has to be properly recognized and respected, and all the musical practices that emerge on different cultures. We should make sure that we recognize their identity, their relevance, and their importance. Okay? Another aspect, especially very relevant, of course, from the academic and the public sector, is this idea that we are very much interested that these AI systems should promote learning, appreciation, and the preservation of diverse musical traditions. Okay, so that these AI systems that for which we develop technologies, they should not be just, let's say, pure entertainment, pure technological concerns, pure monetary aspects that drive our effort, but that this cultural enrichment aspect, this educational aspect of these technologies should play a very important role in what we do, and that AI can promote that aspect of our activities and music in general. Okay. Another very well discussed aspect is the bias awareness, and the idea that researchers, we should recognize, monitor, and address biases in data algorithms and outputs, so that we should be constantly looking for ways to try to minimize these biases that, of course, are a core part of whatever data-driven methodologies we do, and any research. There is biases that come from the fact that we have a particular context, that the data comes from a particular set of cultures or of repertoires. So that generates a lot of biases, but we should make sure that we are aware of them, that we monitor, and whenever possible, we minimize these biases. But for sure, at least be very transparent about them, and do not claim that we are developing AI systems that can be of use in any place and for any context, but that they are really bound by the context that many of the decisions and many of the data and many of the processes we use have. Okay, and then another very important aspect for us and for I would say most of the people involved in music is that human-machine collaboration is a core part of what we should be promoting. That AI systems should act as creative partners while ensuring that humans retain oversight, decision-making power, and final responsibility. Okay, so we don't want AI systems that are completely autonomous. We don't want AI systems that basically substitute the creative practice. And we want to develop AI systems that support our creativity, that interact with musicians, and that therefore can be a complement, can be used to enrich our musical creativity. Okay, and finally, the last well-discussed topic in AI ethics is the idea that we should make sure to develop sustainable AI systems. That researchers should explore efficient AI models and responsible use of computational resources. So when we develop AI systems, many times we don't pay much attention to that, and if we have access to big computational resources, we try to exploit as much as we can that potential, and don't pay much attention to of course, the sustainability of all of that, and the efficiency of what we do. And clearly, that should not be the case. We should make sure, independently of whether we have access to big resources or not, that all the models we do, all the algorithms we develop, should take that into consideration, and efficiency should be an important aspect of the resources that we are using, and the technologies we are developing. Okay, and that was the general idea about these ethical principles within Trustworthy AI. And now let me go to some examples that come from our research at the Music Technology Group, and that hopefully exemplify the ideas and the practices that we are trying to carry out, and we want to emphasize, and that help support all these trustworthy AI contexts that I just described. So this diagram that comes from a current project that we have, which is a chair on AI and music, that aims to develop AI technologies to support the whole music ecosystem, and that summarizes, I believe, quite a big number of the current research that is being done within the field of MIR, which is this idea of developing models, AI models that are trained on as much data as possible, and then they're fine-tuned for particular task. So we see here, we start from data that we gather. Nowadays, maybe most of the models being developed do not include all this data. They might include only partial part of that, but the aim, and our aim, is to try to get as many types of data that can be used to understand music, and therefore that would include audio, text, meaning all the writings that are about music, all the musical scores, images, and that might be scan images, or they can be considered like the videos of performances. And finally, all the metadata that is typically accompanying the audio recordings or other types of sources of data. And with that, the idea is that we have a self-supervised approach in which we can have large-scale models. Sometimes we call these foundational models that have the sort of the knowledge, or at least it has captured as many types of relationships and patterns that exist in all these training data. And that generates this embedding. Hopefully these are semantic embeddings that can capture all these patterns that we are interested in. But then to solve specific tasks, and these are some of the tasks that we would be typically considering and that we are working on, like tagging, captioning, transcription, musicological description, music identification, text query, source separation, generative music and audio. They can be developed by adding further data, further more precise annotations, precise feedback from experts so that we can then fine-tune these large models and therefore in a supervised manner, and that can solve specific tasks that we are interested in. Okay, so that's very much a quite big view of the type of research framework that most of us are having. And then if we talk about specific examples of things that we have been doing or we are doing now, let me mention a few. So, for example, this is a report that we are finishing for the European Commission in order to help the European Commission support all the regulations that are being developed, especially the AI Act. The AI Act is a regulatory framework that aims to support the AI development and aims to give guidelines of what should be done by all the stakeholders developing AI systems. So they ask us to write a report on the solutions for marking and detecting and identifying AI-generated music content, and therefore with the idea to support the transparency requirements that the AI Act has. No? And this has been a quite interesting work in which we have been talking with many people, many of the stakeholders, to try to define what is really the state of the art on this, on marking, detecting, and identifying. And of course, we have to recognize that the technology is not really up to the ideal requirements that the AI Act and the European Union and many countries would like to have, a way that we could mark all AI-generated content and that would be robust and that would be able to support all the current legislation and regulations. But anyway, this is a good, important research tasks that need to be done in order to make sure that we have technologies that can support these ethical and these now very much criteria that the society is demanding. Another fundamental aspects that relate to all these trustworthy AI is clearly the idea that we should make sure that we work within open science frameworks. In the sense that all the research processes, that the data, the tools, the results are openly accessible and reusable, so therefore other researchers can build on and also in fact companies can learn from and can develop their technologies and commercialize their products. At the MTG, we have been very much within those ideas for a long time, and two core projects or initiatives that we have been working on for quite a number of years have been the freesound.org sound repository, which is a collaborative sound repository that people can share sounds with the community and can specify the rights that they are willing to give to other people so that they can use legally their sounds, and it has become a fundamental data set or corpus of sounds that is very much used by many people, both research and commercial initiatives. So that's a good sort of research project that is having a good impact in all these, let's say, trustworthy AI framework. The other project that we have been working on for a long time is the Sentia Library, which is a collection of open source software and AI models. and again with the aim to make them available openly for research, and we also have a way to license them for industrial applications. Clearly, there is some aspects of copyright that we have to be aware of, but we are trying to make sure that all these software, all these models can be properly shared as openly as possible, and that can have as much impact to advance the field as we can. And the area of machine learning models is clearly the one that is growing the most. And within Essentia, we are sharing and releasing a lot of quite interesting models that can be used by other people, by the community. Okay, another and related very much with this Essentia library is the actual AI models and how to develop them in an open manner. And of course, when we were talking about open software and free software, that had a very clear set of considerations and things to worry about. Now, with the idea of open AI models, that's a completely different thing, and it's much more complicated. An AI model is not to make it open, is not just making it the weights open, but there is all the training data, there is the code, there is the documentation, and how to make it really accessible and reusable by the community. And that's not that easy, and it still has not been properly, let's say, formalize what that means. So again, within this Essentia framework that I mentioned, we have been releasing a lot of models. One of the most recent ones is this OMAR, which is open music audio representation, trained with a lot of music data, and we are making it available for research. And of course, here there is a lot of challenges on the training data. A lot of the training data is copyrighted data, so therefore, as for some applications, this cannot be used commercially. So we have to make sure that we comply with all this copyright and all the legal frameworks, which again, it's still not very clearly defined. It's a gray area, but clearly there is exceptions in Europe for research, so we can perfectly share this independently of the copyright context for research, and that's fundamental for advancing the research in this field. But it has a lot of very interesting research issues that have to be addressed, both, of course, in the way to develop the model, the way that we make sure that is as transparent as possible, and that we explain everything that is being done, that the architecture is transparent, and that training data is clearly identified, and that these can be used by other people to build on. So that's a big current challenge from research, and we definitely are trying to contribute to that. Okay. Another important aspect that also, when talking about the ethical issues I mentioned, is this idea that we want to make sure that we are aware and that we are sensitive to all the musical cultures that exist, and therefore the work that we do, and the analysis of music that we should do should be very much aware of this cultural diversity of a specific culture. So the idea that we should make sure to design systems that understand and respect the cultural context of the music they analyze. And in this diagram, I am referring to a large project that we have been carrying out, which we call Comp Music, in which we have studied a number of music traditions, and we have made sure that we are, of course, talking and involving the practitioners, the musicians, the researchers that are specialists in those music traditions, that we develop methodologies, signal processing, machine learning, semantic analysis, that take that into account, and that the musical applications we built from that, the melodic analysis, rhythmic analysis, etc., and the specific applications are adequate for those music traditions, and that we are developing technologies that are very much aware of the specificities of those traditions. Okay, and they don't just consider everything a single set of data and a single set of challenges that are agnostic to specific music traditions. So anyway, so that's a fundamental aspect to be considered, and that we are very much working on. And of course, in order to do that, the data sets, which is arguably the most important bottleneck for good AI models in music, required to take into account all this diversity. So within this ComMusic, that we have worked on these 5 music traditions: Carnatic, Hindustani from India, Makam music from Turkey, Shinju music from China, and Andalusian, Arab Andalusian music tradition, which is now alive in the north of Africa. So we have developed data sets that try to capture the richness of these music traditions. So we have to, as it says here, we have to collect, organize, and maintain data sets that represent a wide range of musical styles, cultures, languages, and contexts. So in this case, we try to make sure that, of course, all the Indian music on the local languages, all the Turkish Makam music in Turkish, in the Shinju in Chinese, Andalusian in Arab, and that we collected data that represented those traditions, and that would allow us to make justice, let's say, to the identities of these traditions. And of course, we are making this openly available for research, and already many researchers have used them to advance MIR research, or in general musicological research on these music traditions. Okay, another element of what I have been talking about is the actual architectures, the actual algorithms that are developed to do these deep learning models, and that to solve a specific task. And one element that from an academic and from our this trustworthy AI framework is very important, is the idea that these models should be interpretable, so that we should develop AI systems whose internal mechanisms and decision-making processes are understandable to humans, so that we can look into the model, we can look into the different layers of what the model is doing, and be able to understand what it's learning, be able to understand what it's doing, how it's processing. So, for example, this is a paper that we published at Decades, in which Pablo Cinemañas, who is this is his PhD dissertation, worked on interpretable deep learning models for sound classification, in which the idea is to develop this prototype layer within the model, in which the values that are there, the representation that is there, can be interpreted, and in this case even can be heard. So we can convert this representation into sound, and therefore with that try to identify or understand what is the sound that is learning to represent a particular class of sounds, so that then we can look into that and see what the model is considering as an example, a prototypical example of a particular sound class. And that allows us then, therefore, to understand better the model that performs this classification. Okay, so we are finishing, so let me talk a couple more things that I believe are important and can exemplify some of the work that we are doing. Another recent paper is this paper that the first author is Benno Weck, and this is again part of his PhD work, and the system is called Mucho Music, that is related to the evaluation of all these systems. You know? So the idea that we should try to promote a fair and transparent evaluation, and therefore develop benchmarks that can fairly and transparently evaluate AI systems performance. And the idea here was to develop a framework that would allow us to really get closer to evaluating the music understanding aspect of machine learning models. So many times we say, okay, this is a great model because it performs a particular task, but does it really understand music? Does it really understand all these dimensions that music has? So we develop a framework with questionnaires, with concepts that we would target for, that would allow us to understand if a particular model was capable of understanding particular musically relevant dimensions or particularly musical aspects. No? And it clearly, the result showed that the 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 capacity of most of or all of the currently available models that claim to do music analysis are not really that capable of understanding the core elements of what music is. They might be able to perform tasks that are well defined, but they are not able to really understand concepts of harmony, melody, instrumentation, understanding the structural aspects of music, etc. And that's also, again, quite relevant if we want to make sure that we develop trustworthy AI models that can be believed in, and that can be that we can trust, and that we can make sure that they do what we claim they do. And finally, the last example I wanted to mention is about creative tools. So we want to make sure that we develop technologies that can be actually useful for musicians, and that we can have open models that can be used by musicians to create music or to do other tasks. So recently we put together this MTG toolbox that aims to do that. No? So the idea again is to develop AI-powered tools that support and augment human creativity in tasks like composition, performance, and production. So in this MTG toolbox, we have gathered a number of tools, most of them deep learning tools, that can be actually used directly by a final user. So a lot of the research we do generates a paper, generates some code, but typically is not that easily accessible by musicians, by people that want to do music with. So here we made a special effort in trying to gather some of the tools that we have been developing that can be actually easily accessible by musicians. And that's a very important way to make sure that the technologies, that the AI research that we do reaches the musicians, which is at the end one of the most important stakeholders that we should be supporting and that are responsible for making all this ecosystem of the music successful, and that we can all enjoy this culture. And that's also, let me just give some final takeaways that I have been trying to emphasize through the talk, but I want to summarize here. The first is this idea that trustworthy AI raises new research challenges, okay? That all these issues of legal compliance, transparency, accountability, efficiency, and verifiability, they actually open research questions on how to do research, on how to design, how to evaluate, and how to deploy music AI. So these are new or sort of important topics that, as researchers, we should try to work on so that the whole trustworthy AI ecosystems can be successful. Okay, that's one. The other point that I also mentioned is this idea that these ethical principles that I would say most of us would agree with, and that society has also been very much verbal about that and has been proposing. And we should use them really to guide our MIR research. So our MIR research should be based on respect for creators, should support cultural diversity, fairness, and human oversight. And these are fundamental components for all these trustworthy AI innovation that we should be aiming for. Okay, another aspect that we should be very much working within is this idea that open science and believing very much that all this openness is fundamental for an impact of our research. So the idea that we should open data sets, models, and tools, and these are fundamental for reproducibility, for community validation, and for broader cultural and societal benefit. So especially nowadays that the AI is moving towards these closed models, that these large corporations are really bringing tools that are definitely not in this direction. From the public sector, from the research community, we should try to offer alternatives that can make sure that have an open perspective and that can have a benefit in a broad way. And finally, the last aspect I wanted to mention is the idea that collaboration is essential. As we all know, AI is a field that requires huge resources, huge teams if we want to have an impact. And if we are not a large corporation, the only way to try to do that is by collaborating. So we have to address these challenges by cooperating among researchers, artists, industry, policymakers, and communities. So try to develop initiatives, projects that try to take advantage of this collaboration in order to have a relevant impact. And that's all I wanted to say. So thank you very much. And hopefully that has given some very general insight on my view of all this trustworthy AI and the research on MIR. And hopefully you enjoyed it. Thank you.